Example 1. Committee of 3 teens. A club consists of 4 kids and 5 teens. 3 members are to be selected at random to form a committee. What is the probability that the committee will consist of 3 teens? Okay, first, you see how we have probability now. So let's just pull out what it's asking. That's always your first step with a word problem or an application is pull out what are they asking? What's the question here? So they want to know the probability of 3 teens. So they want to know the probability of 3 teens. We could put 3T for teens. So because this is probability, we know it's a fraction. Probability is all fractions because probability exists between 0 and 1. 0 and 1, those are all decimals, aka fractions. So what we put on top of every probability is what you want. Like, what is the outcome that you possibly want? So what it wants is a committee that consists of 3 teens. So we want to know how many types of 3-teen committees can we have? That's saying we're looking for the number of combos with 3 teens because we want to know if we just looked at the teenagers, how many can we mix and match together? And the bottom is always your total of everything you're talking about. So in this case, we're talking about a 3-member committee. So we have to find the combination for each of these, just the teens, and then what if we talked about everybody? So let's find our 3 teens. So we have to identify our N and our R. So your R is how many are you picking? Well, we're picking 3 people. And out of that, all the teens, we have 5 teenagers. So our N is 5. So when we set this up in our combination formula, remember our combination formula is NCR equals n factorial over n minus r factorial. Now that you've done combinations already and you should be using your calculator, and even if you are doing it by hand, you know how to do combinations. So I'm not going to actually spell it all out. I'm just going to write it in the formula. So if we wrote it in our formula, we have blank factorial over blank minus blank factorial, blank factorial. Our first blank is n, so is our second one. Our next 2 blanks are R, which represent 3. And when you put that together, we get 10. So our answer for number of combos with 3 teens, there's 10 ways you can mix and match 3 teenagers out of 5 teenagers. Alright, now let's do all of it. What if we just put in teens with the kids? What are the possible combinations? So we need just 3 member committees. So our N and our R. When you're doing probability and combinations, your R never changes because we still need a 3-member committee. So our R is still 3. Now we just need the total of everyone we have. So there's 4 kids and 5 teens. That means there's 9 total people that we can pick from. So that means we have 9 factorial over 9 factorial minus 3 factorial, 3 factorial. And you get 84. Now 10 and 84, they're both even, so if you divide by 2, you get 5 over 42. You can no longer simplify because 5 is prime. So the possibility of a 3-team committee is 5 over 42. Alright, let's talk about poker. A flush in the game of poker is 5 cards of the same suit. So you either have 5 hearts, 5 diamonds, 5 spades, or 5 clubs in your hand. So you have all the same picture, not like you have the same shape, like the little clover or the diamond, stuff like that, and they're all the same color. So if you are dealt a 5-card hand, determine the probability that you will be dealt a heart flush. Alright, so we want to know the probability that you are dealt a heart flush. So what that means is you have 5 hearts in your hand. You have 5 heart cards. So, because this is probability, we set it up as a fraction. You always put what you want on top. So what we want is a heart flush. So we need the number of combos of 5 hearts. So it's meaning if we took all the hearts out of the deck, how many ways can we mix and match to have 5 of them in our hand? The bottom is always your total of everything. So instead of just heart flushes, we want to know if we look at the whole deck, how many types of 5-card flushes can we get? Alright, so let's find our 5 hearts first. So we need our N and our R. So our N, that's how many hearts you have. You have 13 heart cards. And you're picking 5 because you have 5 cards in your hand. So that means we have 13 factorial over 13 minus 5 factorial, 5 factorial. And when you plug that into your calculator, you get 33. So there's 33 different ways you can mix and match 5 of your heart cards in your hand. Now we need to know all of it. Your 5-card flushes. We need to know all types of 5-card flushes. So we still need our N and our R. Remember, your R is never going to change because you can only have 5 cards in your hand. But this time we're not looking at just flushes, we're looking at all the cards in a deck. We have 52 cards in a deck. This is why I'm saying you need to use a calculator. You're not going to want to do 52 factorial. That's a lot. So we have 52 factorial over 52 minus 5 factorial, 5 factorial. And when you plug that into your calculator, you're going to get 66,640 different 5-card flushes. Now, you're going to have to plug this into your calculator no matter what. When you plug this into a calculator, you might get a decimal or you're going to get a weird answer. I'll show you what weird answer you're going to get on your calculator. It's going to look like this. So, I'm sure you've played with your calculator a little bit and you get weird answers that look like this. They have that little E to the whatever next to it. So, when we think about negative in numbers, that means to the left. Positive is to the right. So what this is actually telling you to do is move your decimal 4 places to the left. So if we move it 4 places to the left, we have 3 zeros. So we actually have 0.0004951980792, which if we wanted to just round that to a nicer number, let's say 0.000495. So that's the decimal. If you want a percent there, .05%. So to get a 5 hearts in your hand, if you want a heart flush, it's half of a percent. Half of a percent. Woo! That's wild. That's so rare. Example 3, streaming queue selection. Hermes has shows in their queue they want to watch. They have 4 iCarly episodes, 5 Orville episodes, and 3 Toast of London episodes in their queue. If Hermes queues 4 episodes and presses the shuffle button, determine the probability that no iCarly episodes are selected, at least 1 iCarly episode is selected, and 2 iCarly episodes and 2 Orville episodes are selected. Alright, let's do A. So we want the probability that you have no iCarly episodes. Alright, so on top, that's what you want. That's what you're trying to find. That's what we want. Number of possible not iCarly episodes. And then your bottom is the total. So we're talking about episodes. So that's number of all possible episodes. Possible means combinations. Let me just change that word to combinations. That's the word I've been using. Alright, so let's do our top. Alright, so we're only looking at iCarly episodes. So we need our N and our R. So we're picking 4 episodes. And then we actually have so let's look at the rest of the episodes that we don't have to pick from because we just want to look at the ones that are not this. So we have 5 and 3 that are not that. So 5 plus 3, we have 8 episodes that we can pick from. We're picking 4 out of the 8 that are not this. So let's go ahead and put it into our combination formula. So we have 8 factorial over 8 minus 4 factorial, 4 factorial. And when you plug that in, you will get 70. So there's 70 ways you can mix and match the rest of those episodes if you're going to queue 4 of them. Now let's do the total of all episodes. So let's just not be picky. We have to look at the total combinations of all episodes if we're picking 4. So our picks don't change. Your R is still going to be 4. Your R will never change. The only thing that's changing is our N. So if we look at how many episodes we have 4 plus 5 plus 3. That's 12 episodes that we have total to queue. So we have 12 factorial over 12 minus 4 factorial, 4 factorial. And when we plug that in, we get 495. Because these are both 0 and 5, it ends with a 0, it ends with the 5, you can actually divide by 5. When you divide by 5, we're left with 14 over 99, and you cannot go from there. That's simplified. That's about 14 and a half, almost 15%. Alright, B. We need at least one iCarly episode. Do you see it? Do you see that little formula thing from like 11.5? When we had the none and some, part C and part, or yeah, it was part C and part D of the last example, example 7 and 11.5. That's coming back again because none and at least one are opposites of each other. So remember, if you're talking about no and at least one or none and at least one, if you have one, you can find the other by just subtracting by one. So the probability of at least one iCarly episode equals 1 minus the probability of no iCarly episodes. So we have 1 minus the probability of no iCarly episodes, which was 14 over 99. So we technically have 99 over 99. Remember, you just take the denominator if it's 1 next to it. Minus 14 over 99, and we get 85 over 99, which is about 85%. Now, you could set this up like A, but at least one is extremely hard to find. It's just very complicated. You can try it, it's doable. It's just very, very complicated. Sometimes let's say the question is find at least one. It's actually easier a lot of the time to find none than subtract it by one. So let's say the example was just part B. Part A and part C didn't exist. But you know what's easier? Do part A, then get to part B. So you say find none, that'll give you at least one. Alrighty, part C. We want to queue up 4 episodes, but 2 of them must be iCarly and 2 must be Orville. Alright, this is very similar to like the restaurant question where you had columns to pick from. So here we're picking 2 different sets here. We're picking combinations. So that means let's spell out the probability it wants us to find. It wants us to find the probability of 2 iCarly episodes and then 2 Orville. We'll do OR, so we know that's an O and not a 0. Alright, so that means we need to find the combinations of both. So we need to find the combinations of 2 iCarly episodes. And then we're going to multiply it to the combinations of 2 Orville episodes. And your bottom never changed. That's always your total combos. We actually already have that answer. It's 495. Because that doesn't change. We're still picking 4 out of 12 episodes for the total combination. So we actually have that answer. So let's go ahead and put it. It's 495. Alright, now we need to find our 2 iCarly episode combos. So this case, we're picking 2 iCarly episodes out of a total of 4 iCarly episodes. So we have 4 factorial over 4 minus 2 factorial, which simplifies down to 6. So if you're picking 2 out of 4 iCarly episodes, there's 6 ways to mix and match your episodes. Alright, now we need to do our combinations of Orville. So we're picking 2 Orville episodes, and total we have 5 to choose from. So that means we have 5 factorial over 5 minus 2 factorial, which comes out to 10. Alright, let's simplify. 6 times 10, we get 60 over 495. You can actually keep dividing by 2 several times, or you can divide by 10 and then 2. So it simplifies to 4 over 33. Alright, our last example of 11.9 is extremely similar. Like the example 3 was very similar to the combinations at your local restaurant, but example 4 is exactly like it, but just using combination probability. So we have a rare coin collection. It's made of 8 silver dollars, 7 quarters, and 5 dimes. We plan to sell 8 of the 20 coins to finance a new gaming PC. If they select the coins at random, what is the probability that 3 silver dollars, 2 quarters, and 3 dimes are selected? So let's pull out the probability. It wants the probability that 3 silver dollars, 2 quarters, and 3 dimes are selected. So it wants to know the probability of 3 silver dollars, 2 quarters, and 3 dimes. So that's what we're trying to find. Guess what? That's what goes on top. We need to know the combinations of 3 silver dollars. And then we need to find the combo of 2 quarters. And then we need to find the combo of 3 dimes. And remember, the bottom, no matter what, is always your total. So that's everything you're talking about, not just different categories. So let's go ahead and find our silver dollars. All right, so we're selling 8 out of 20 coins. So that means we want to pick 8 to sell. And we have 3 silver dollars that we want to pick. So we have 8 factorial over 8 minus 3 factorial, 3 factorial. And that comes out to 56. And if you're wondering, how do we know we're planning 8 to sell 8 out of 20? That's what it says right here. We're selling 8 out of 20. And there are 8 silver dollars to pick from. But we only want to pick 3 of them. Now let's do quarters. So we want to pick 2 quarters out of all the quarters we have. Remember, the top part, you're just looking at each category. So you're looking just at the silver, just at the quarters, just at the dimes, each individually. So we want to pick 2 quarters. We have a total of 7 quarters to pick from. So that's 7 factorial over 7 minus 2 factorial, which comes out to 21. And last but not least, we have our 3 dimes. So we're picking 3 dimes, and we have 5 dimes to pick from. So we have 5 factorial over 5 minus 3 factorial, 3 factorial, and that comes out to 10. All right, now we need to find the total combinations of all of them. So it told us that we're picking 8 out of 20 coins. So we have 20 coins to pick from, and we're selling 8 of them. Also, 3 plus 2 plus 2. 3 plus 2 plus 3, that's 8. So our total combination, we have 20 factorial over 20 minus 8 factorial, 8 factorial, and we get 125,970. All right, now we need to multiply our combinations on top to figure out if we picked all of them together, how many do we have? So 56 times 21 times 10, we get 11,760. And then we have 125,970 on the bottom. You can divide by 10 3 times. So you can actually divide by 30 to get 392 over 4,199.